So here we have to show the derivative of y with respect to x is given by the following expression whenever we have an implicit function given by sine of y equals to x times sine of a plus y. Now let's begin with this particular implicit function only. So we are given sine of y that's equals to x multiplied to sine of a plus y. Let's take the derivative on both sides with respect to x. We have derivative with respect to x of sine y, which is equals to derivative with respect to x of x times sine of a plus y. We know the derivative of the sine function gives us the cosine function. Since we have y, so we'll have cosine of y, but we'll also have to multiply it to derivative of y with respect to x, which is obtained as a consequence of the chain rule. Now, to take the derivative of x times sine of a plus y with respect to x, we'll have to use the product rule. So here we have derivative with respect to x of x, so this will get multiplied to sine of a plus y plus x times derivative with respect to x of sine of a plus y. Right. So this gives us cosine of y multiplied to derivative of y with respect to x equals to the derivative of x with respect to x is simply 1. So we have sine of a plus y plus x times the derivative of the sine function is going to give us cosine function. Here we have a plus y, so we'll get cosine of a plus y, but we'll have to use the chain rule and we'll multiply it to derivative with respect to x of a plus y. So this is going to now give us cosine of y times derivative of y with respect to x equals to sine of a plus y plus x times cosine of a plus y times, so we have derivative of a is a constant, so it will be 0 plus derivative of y with respect to x. So what we'll do, we'll transpose the second term to the left hand side. I will have cosine of y minus x times cosine of a plus y whole multiplied to derivative of y with respect to x. So this will be equals to sine of a plus y. Now we'll divide each side with the coefficient of dy over dx. So this is going to give us derivative of y with respect to x equals to, so in the numerator we have sine of a plus y, and in the denominator we have cosine of y minus x times cosine of a plus y. Now if we look at our original problem, we need to have a sine squared times a plus y in the numerator. So what we'll do, we are going to multiply both numerator and denominator with sine a plus y. So in the numerator we have sine squared times a plus y divided by, so we're going to multiply sine a plus y to each term. So we have sine of a plus y multiplied to cosine of y minus x times sine of a plus y multiplied to cosine of a plus y. Now in the denominator, in the second term, we have x times sine of a plus y. Now this is actually equals to sine y, because if we consider our original implicit function, we have sine of y equals to x times sine of a plus y. Now that means we can replace this with sine y. So let's rewrite everything. So we now have derivative of y with respect to x. So that's given by sine squared a plus y divided by sine of a plus y multiplied to cosine of y minus sine of y multiplied to cosine of a plus y. Now here we are going to use the facts that whenever we have sine a minus b, so that's given by sine of a times cosine of b minus cosine of a times sine b. So here if we assume a to be equals to a plus y and b to be equals to y, then this entire expression in the denominator can be reduced to, we have dy over dx equals to sine squared a plus y. So our denominator will be sine of a minus b. So a here is a plus y minus b, which is y. So the y and y gets cancelled, and that leaves us with sine squared times a plus y divided by sine of a. So therefore we have successfully shown that derivative of y with respect to x, that's given by sine squared a plus y whole divided by sine a. So this is what we are asked to show, hence proved.